Hello, everybody. My name is Jordan Clayton from Freqs, and this is the video that I promised to make at the end of my last video. This will be on coding the front-end Streamlit web application that we use to demonstrate the blockchain coded in the last video. So we left off in the last video right around the chain. This is the last block of code that we coded for the blockchain in the last one. This is the class where we defined a proof of work function, linked the blocks together in the blockchain, and defined a validation function. We're going to begin the Streamlit code here. So the first thing that we're going to do is add the Streamlit cache decorator. Now I want to cover some basics here on this because it's going to help a lot with the rest of the code if we understand this properly. So I pulled up the Streamlit documentation. And here we have the Streamlit cache. And let's just understand that. So when you mark a function with Streamlit's cache annotation, it tells Streamlit that whenever the function is called, it should check three things: the name of the function, the actual code that makes up the body of the function, the input parameters that you called the function with. Then if this is the first time Streamlit has seen those three items with those exact values and in the exact combination, it runs the function and stores the results in a local cache. The next time the function is called, if those three values have not changed, Streamlit knows it can skip executing the function altogether. Instead, it just reads the output from the local cache and passes it onto the caller. The main limitation is that Streamlit's cache function feature, or that Streamlit's cache feature doesn't know about changes that take place outside the body of the annotation function. So this is where, and then so what we'll be actually using is the allow output mutation in the cache function. We want to set that equal to true. So Streamlit shows a warning when return values are changed, as that can have unintended consequences. This is done by hashing the return value internally. If you know what you're doing and would like to override this warning, set it to true. This is what we want to happen. So now that we understand that, we're going to go ahead and go Streamlit cache. Geez. Allow output mutation equals true. We want the capital true, the Boolean value. All right. And then we're going to define the setup. So this, let's put an initializing message in the setup here. So now we're communicating with the Streamlit. So print initializing chain. So that's the string we want to show at the beginning there. All right, and then we're going to create a new instance of the PyChain class that we just reviewed, and we're going to pass it a list of block objects, and the first block in the list is going to be the Genesis block. So we'll return PyChain. There it is, and then we're going to pass it a list of block objects, and we want it to start at index 0. So the first one, and that will be Genesis block. So we're saying return PyChain block class, and we're going to take that first index value 0. That will be the Genesis block. So now we want to, I'm going to just add like a main header. And so to do that, we'll just do Streamlit Markdown. And so we're just telling it that we're going to use Markdown. We're going to use the Markdown formatting. And we will do a string. This is going to be our main header. PyChain is what we shall call it. Python chain. Then we're going to add a little sub header here with the double hash marks, and we'll say store a transaction record in the chain. I'll point out where these are in the code once we get this up and running. Okay, and then we want to, so we want to call this, creating this function, and we're going to call this and um, we're going to store what's returned in a variable. So, and we're just going to do lowercase PyChain. And setup. Cool. Okay, so we want to get some user input here into our application. So one of the first things that we're going to have them enter is the sender information. So let's go ahead and create a sender variable. We're going to set that equal to streamlit.text input. So this is going to create a text box. And that text box will say sender info. So just going to say sender info, then there'll be an input text box that we can input some string information. And then we're going to say receiver is the next information that we want to have the user enter. Receiver streamlit.text input. And here we'll have the receiver info. Cool. And then we also want to have them enter the amount of the transaction that they would like to transact. So Streamlit, this one will be a number input, and then we'll say amount. Straightforward. I like it. All right, so next we're going to add a Streamlit button, a button in the Streamlit application. We're going to put that in an if statement. So we're going to say if this button is pushed, these are the things that we want to occur. So if Streamlit dot button, and then we'll just call that that button add block. So then what happens when we push this button? So we want, the first thing that we want to happen is to grab the previous block. And so we will call the PyChain variable that we created over here and say PyChain.chain and grab the very last block in the chain. PyChain over is the results of our definition, our setup function definition, and then chain is an attribute in the PyChain class, which is a list of block objects, and the block objects are have all of these attributes and have the hashing function that encodes and then returns a hash function with all of the coded information for these attributes. And the next thing we want to know, we want to grab, is the previous block hash. And so we will get the previous block, which we just created above, and we will say hash block. I'm going to call hash block, which again, hash block was up here in the block class, and that's the encoding and returning of the hash function. Okay, so the next thing we want to happen in our button, after our button is pushed, is we want to have a new variable. We're going to name it new block, and that will be block data class, and it will be the attribute record of type record. So we're going to say block. We're going to pass a few things through here. So record equals type record. We want the creator ID. This will be the creator ID of the block. We're going to set that equal to 42 because, of course, 42 is the answer to life, the universe, and everything. Please tell me in the comments if you actually get that reference. We will be friends. And then the previous hash is going to equal the previous block hash. Yes. All right. So we'll come outside of our new block, but we still want to be within our if statement, and we will say PyChain dot, we're going to add the block, we're going to add block, and we will pass new block through there. So new block will be the block that is added to the PyChain function. Okay, now this next part, very important. Please pay attention, or you will be left behind. Streamlit dot, this is what will happen at the very, very end. The last thing we'll put into our button balloons. Balloons. Told you that we would code the balloons in the last video. There it is, just happened. So now let's add another markdown. We are going to add the ledger. So we want to be able to view this whole thing. So Streamlit markdown once again, and then we'll do a sub header and say they chain ledger. So this is the subheader where we'll put that'll be displayed right in front of it. All right, so then we're going to define a new variable and pass the PyChain.chain, which we'd find above. PyChain being the variable that stores a setup function, once again, that's composed of the chain blocks. .chain being the attribute that we are accessing that was defined in the PyChain class as a list of block objects. So we shall say PyChain. What we're doing is we're going to create a data frame of this stuff. So we have, here we go, so pd.pandas.dataframe, and then we're going to pass through data frame PyChain dot chain. And then we want to store that as type string so that we can read it. So we want to convert the chain of blocks. We want to convert the chain of blocks. We want to convert the chain of blocks to a data frame and then convert the data frame to a string. All right. And then we will streamlit.write PyChain data frame. PyChain data frame. So all this is doing is telling us that we want to write the data frame into the web app. So it'll be displayed. The results of that will be displayed. All right, so the next thing that we're going to define in the web application is going to be the slider. So the slider for the difficulty that will control the difficulty of the proof of work function that we defined earlier. Well, not earlier, but in the previous video. Kind of go through that here. So we'll do the Streamlit. Let's start with difficulty. Difficulty is going to be streamlit.sidebar, so it's going to be on the side of the web application, and then it's going to be a slider, and we're going to call that slider block difficulty, and then we're going to say 1, 5, and 2. Let me explain. So that's the block difficulty slider with a minimum value, a maximum value, and a starting value. So when you start this application, it'll automatically start it to 2. The minimum value will be 1. The maximum value will be 5. Okay, so after difficulty, we want to say PyChain dot difficulty is going to equal difficulty. We're setting the difficulty of the chain to the value of the slider. So the PyChain, so we're saying PyChain difficulty, which is basically this value here. since PyChain calls to the PyChain data class and this difficulty variable, which we initially set to an integer of 4, and we are saying that it's going to be equal to this difficulty, which is dictated by the slider. Okay, so next we're going to code what we'll call the block inspector. It's where we're going to be able to select a specific block within the ledger and check it out, look into it, get some details. So to do that, we'll start with the Sreamlit sidebar. This will be another sidebar application, and then write, and I feel like a Sreamlit sidebar dot write, and we're going to give it a header of block inspector using markdown format. All right, define a new variable. Selected block is going to equal Sreamlit sidebar dot select box. So it's going to be a little box that we're able to make selections with. Within that select box, we're going to pass a string, which block do you want to inspect? Inspect question mark. And then we need to go into the PyChain dot chain. So this will allow us to select a block from the chain. Last button we're going to add to this application is going to be the validate chain button. We're going to take advantage of the validation function that we wrote in the blockchain earlier and display the results of that in the web application. So we'll start with if again, and then Sreamlit button, and then we'll say validate chain. Cool. And then Sreamlit.write. We want to write that into the Sreamlit application. PyChain, our entire PyChain class and list of objects, is valid. Okay. All right, let's go through the isValid function coded earlier in the blockchain video to make sure that we understand what's going on here with this function. Just to recap it. All right, so here we are in our PyChain class, and our isValid function definition is here. So the first thing we're doing is we're creating a variable block hash, setting that equal to self.chain, and going to the genesis block, so the very first block that's being created, and grabbing the hash block, which is going to be this hash function that has all this data encoded within it. And then we're going to create a for loop to iterate through the list of block objects. So we're going to say for block in self.chain, which is our list of block objects, as you can see here. And starting at index 1, notice that this is index 0. So in the next block, starting at index 1 and all previous blocks after that, if the block hash is not equal to the previous hash in the current block, print blockchain is invalid and return false. And then we're going to set, if that's not true, we're going to set the block hash equal to the hashing function of the current block. And then print blockchain is valid, return true. So if this is not true, so if this is true, then it's going to go to this next step and then print blockchain is invalid. If this is true, it'll print false, so it's going to stop here. All right. Let's go ahead and visualize this once again. Okay, so as mentioned in the last one, make sure that you are in the correct directory where you can find your app that you are coding in here, the Streamlit application, and also make sure you are in the correct environment, Anaconda environment, if you've got one in there. So you'll want to have your Streamlit, pip install Streamlit in there. And then we'll do Streamlit run app.py, right? And then this will pop up. Here we go, and there it is. This is what we've been working on. So let's see if we can go into here so we can see our stuff and do a little demo. So here's PyChain. This is going to be there we go. PyChain. Store transaction record in chain. There we go. Very good, very good. Sender info, ba-bam. Receiver info, love it. Amount, beautiful. The next we've got our add block button, boom. And then let's see here, where do we go next? The chain ledger. Where's my chain ledger? The chain ledger. And you can see you can actually go into that and you see what information we've got added into there. So let's do a little, let's play around with this just a little. Pop open our terminal so we can see the stuff going on there. So again, receiver 1, or that's backwards. Sender 1, receiver 1, amount 1, add block, balloons, and Genesis block, there we go. Difficulty 2. Let's open this up. Here's the whole ledger. Nonce 0, nonce 43. Creator ID 42. Let's do a couple other. Here's our winning hash. Cool. Notice again 2 leading zeros. Crank it up to 5. Premature balloons. Don't know why that happened, but all right. So let's go ahead and do and update this information. 2 amount. Let's just keep it consistent. 2. Add that block. We are successful. We got a winning hash. We got 5 leading zeros with 5 block difficulty. You just love to see that. Let's do a third one just to really be overachievers here and add that block. All right, you can see our ledger is actually growing, which is what we want to see. Now let's go ahead and validate the chain. True. All right, so this is a fully legitimized ledger. All blocks in the ledger are legitimate. Okay, so again, here's our block difficulty. We made that here. Block difficulty 125. You saw when we started up, we were at 2. Our maximum we can go up to is 5. Minimum is 0. Then we've got our block inspect tool. So which block do you want to inspect? Which block do you want to inspect? All right. Very cool, very cool. Let's just take this one. And what do we got? Did we inspect it? Are we inspecting? Okay, in demonstrating the application, I realized we left something out because when we go into the block inspect and we can go through and click on this, we're not getting a result here. And so what we are missing is we're missing something here at the block inspect. We need to write the results to it. That's what was forgot. So we'll go Streamlit, sidebar, write, selected block. That's all. That's what we're missing. So I don't think we need to rerun this, but let's see. Yeah, let's just go ahead and totally rerun it. All right, let's cancel out of that and go back up to Sreamlit App Run. Let's get that popped open. And that's okay. Receiver 1, receiver 1, that should be sender 1, and that is 1 ad block, and then 2, 2 ad block, 3, oh, gotta change the difficulty, 3, 3 ad block, running. Ah, see, it took a little bit longer that time. The difficulty was higher. All right, now looky here. All right, so now we can select from any of our blocks, and we are displaying our all the same information that you would see in the entire ledger here, just for a single block. So there you have it. All right, once again, Jordan Clayton from Freqs. If you found anything in this video useful or interesting or fun at all or worthwhile, please like, subscribe, do any of those things. Either way, I'm getting a lot of learning out of this process, and it's been a blast. So thanks again for watching.